Hey folks, I'm Mr. Hartzler and I want to talk to you about solving rational equations. And I think the best way to do that is to actually just start off with an example. So right here, looking at the screen, I've got this problem. I need to first get a common denominator on the left side and on the right side. Left side is actually already done, so I just need to get a common denominator on my right side. So between 3k squared and k, I need my least common multiple. LCM is how we refer to that, least common multiple. What is the smallest thing that I can build both of these up to? Well, k and 3k squared, well, this already has a k in it. So this piece here is just missing a 3 and another k. That will get this chunk here up to 3k squared. So this right here, I need to multiply it by 3k, 3k. So I'm just going to write all of that down here. 1 over 6k squared equals 1 over 3k squared minus, and that's now 3k over 3k squared, because again, multiply 3k by that k. Since both of these denominators are the same, I can put both of them over the same thing. So that's now 1 minus 3k all over 3k squared. Then I'm going to multiply by my denominator. You can really start with either one. I've been telling my students the left one, so I'll just do that just so I'm maintaining consistency. So I'm going to multiply both sides by 6k squared. That's the denominator on the left. It cancels on my left, and over there I'm left with a 1. And on the right side, if you don't want to do this, you want to simplify later, that's fine. I'm going to simplify as I'm going. So you'll notice I have a k squared on the denominator, and I have a k squared in the numerator. Because both of these don't have anything being added or subtracted to them, I can cancel those two things. I'm also going to have a 6 on top and a 3 on bottom, and I can actually reduce that. 6 divided by 3 is a 2. So I reduced my 6 over 3 to just a 2 over 1, if you like to think about it that way. Now that 2 is going to get distributed to everything. So I have a 2 minus 6k. Everything on the top ended up canceling with something on the bottom, so I actually didn't have any denominator left. Now, this is a classic one-step problem. Or two-step problem, I guess. 1 equals 2 minus 6k. Need to isolate my variable, so I'm going to subtract 2. So negative 1 equals negative 6k. Divide by negative 6. And I end up with positive 1/6 equals k. I like to check for extraneous solutions. If I plug in a 1/6, none of my denominators end up being 0, so we are all good. Go on to my next problem here. I've got this one. Looking at the left side, it is already simplified. Not simplified rather, but there's already condensed into one term. My right side is 2 terms, so again, I need a common denominator. I'm going to just rewrite this whole thing real quick. 5r. This one is over 1, so I need to build up this denominator to look more like the other one. So I'm going to multiply by 5r over 5r, which is really a fancy looking 1, so I'm not changing the equality. If I'm multiplying by the same thing on top and bottom, I don't have to touch the other side. So now I have an r minus 4 over 5r equals 1 plus 5r times 1 is 5r, and the denominator is going to be the same, so I'm just going to put them over 5r. Now I'm going to multiply by whatever my left denominator is, which is 5r, and I'm going to do that to the right side. If I do it just to the numerator, I have to also do it to my right side of the equation. And it's actually going to cancel on both sides. I ended up having a common denominator on both sides of the equation even, so they're gone. Now I have an r minus 4 equals 1 plus 5r. I'm going to subtract r. Negative 4 equals 1 plus 4r, subtract 1 over, and I'm running out of space. So negative 5 equals 4r, and divide by 4. Negative 5/4 equals r. If I plug that in, I don't end up with any zeros in my denominator, so that answer is good. It is not considered extraneous or extra. All right, look at this one. I've got 1 on the left and 2 terms on my right. Fortunately for me, they already have a common denominator, so all I need to do is put them over that same denominator, 7v minus 42. Now there was a plus in the middle between these two terms. If that were a minus, I would distribute that minus to both those terms. but distributing a plus isn't going to change anything, so I'm going to leave it alone. Now, there's no denominator on the left, so I'm going to multiply by the denominator that I have on the right, and I'm going to do that to both sides. It's an ugly 4, but that's a 4 there. All right, on the right side, it cancels, and on the left side, I end up with v minus 4 times 1, which is just v minus 4. And then that whole numerator, which I probably should have cleaned up earlier, but we'll get to it. 7v and v. I'm going to simplify that on my right side before I do anything else with it. And 2 and negative 42. So that gets me not a positive, but rather a negative. I'm going to add 40. Oh, will this let me erase? Nah, it's not letting me erase. It used to work. It doesn't work anymore. All right, so that's v minus 36 equals 8v. I don't get a tally for all of you that are trying to keep track of that, Ashton and Maddie, but because I caught it beforehand. So negative 36 equals 8v. I'm going to subtract that v. Negative 36 equals positive 7v. And that's a bummer because that's not going to really simplify a whole lot for us. And I'm just going to leave that like that ugly fraction. There we go. Negative 44. All right, I think I'm good there. Okay, next one. I'm here. Okay. You'll notice here that there's two different kinds of n plus stuff on the bottom. They're not going to end up canceling quite as well as we would like, but that's going to be okay. I'm going to still get a common denominator on the right side. My left is only one term hanging out there, so I'm not going to deal with it. That 1 needs an n plus 1. That will give me a common denominator on my right side. So that's going to be just a plus 6 from that term. And now everything's going to be over n plus 1. I'm going to clean this up a little bit. So that's an n plus 1 times 1, so it's not going to change anything. And then plus 6, so that's going to be plus 7 over n plus 1. Okay, now I'm going to multiply by the denominator on my left side. So I'm going to multiply by n plus 8. I'm going to multiply by n plus 8. It cancels on my left. So now I have an n plus 5 equals n plus 7 times n plus 8 all over n plus 1. Now I'm going to multiply by the n plus 1. Cancels on my right side now, just like I did earlier on my left. So now I have n plus 1 times n plus 5 equals n plus 7 times n plus 8. Whew, looking a little bit ugly. That's okay, though. Now you need to FOIL both sides here. Go ahead and do that, and I'm not going to talk through it. You try it, and then you look up here, and you see if you get the same thing as me. All right, well, that was our bell, and detention is now over, so that's nice. All right, I got this. Hopefully I'm not wrong. If I am, just add a tally. All right, now I need to try and clean this up. So I have an n squared on the left, n squared on the right. I need everything over to one side. Minus n squared, minus n squared. Cool thing is, cancel on both sides. I'm going to subtract 6n and subtract 6n. I need to add room, so I'm going up to the top right now. I'm left with a 5 on my left. And 15n minus 6n is going to get me 9n, and then plus 56. I'm going to subtract 56. So I end up with negative 51 equals 9n. Divide by 9. Negative 51 ninths equals 9. Let's keep going. I'm here. Let's try this one. This one, I only have one term on each side. So all I have to do here is, we could also talk about it like cross multiplying. I'm going to multiply that left side and right side by 2x minus 3. Then I'm going to multiply both sides by 5 minus 2x. So that will end up with the 1 on the top left. Let me write this out, actually. I think that will be easier. Come on, little fella. There we go. Erase all ink on the slide. And so I've got 1 over 2x minus 3. I am going to multiply both sides by 5 minus 2x. 5 minus 2x. And multiply both sides by 2x minus 3. 2x minus 3. So on the right, my 5's cancel. And on the left, my 2x's cancel. All right, so I'm left with 5 minus 2x equals 2x minus 3. Need to get everything over to one side. So I'm going to add 2x. I'm going to add 3. 8 equals 4 x's. And finally, for the first time, we get a nice, pretty number. X equals 2. Off we go. Ooh, word problem. But like I've been telling my students lately, if you want to ask how math is used in the real world, you have to ask yourself some word problems. Because life is never set up like the last problems you've seen. They're set up like this situation. So a fountain has 2 drain valves. With one valve open, the fountain completely drains in 4 hours. With only the second valve open, the fountain completely drains in 5¼ hours. About how many hours will a fountain take to completely drain with both valves open? Round your answer to the nearest tenth. Okay. So my first valve does one job in 4 hours. My second fountain does one job in 5.25 hours. I'm adding those two things up because now I'm saying both valves are open. One valve is getting a job done in 4 hours. One that's getting a job done in 5¼ hours. And that's going to be one job getting done in how many total hours? So I need to get a common denominator over here on the left and add those two things up. Or you could plug that all into a calculator. And what do you get here? 1/4 plus 1 over 5¼ Sorry, I don't have a great calculator on me. That's a decimal, so I'm going to keep everything in decimals. And I get 1 over, sorry, I just get 0.44 equals 1 over x. And for my students, if you don't have a calculator on the test, the numbers will be prettier, like a 4 and a 2 or a 4 and a 6, and you'll be able to combine these without using a calculator, just by getting a common denominator. All right, and now I don't like this x in the bottom, so I'm going to multiply by x. Multiply by x. So now I have 0.44x equals 1. And I need to divide by 0.44. And x equals 1 divided by that number. 1 divided by 0.44, and I get about 2.27. But it was specific. It said around to the nearest tenth. So x equals 2.3 hours. Alrighty, folks, that is it. Thank you for watching. I hope all of you have a phenomenal rest of your day. Make sure you keep doing math carefully and with enthusiasm. And, of course, don't do drugs.